Welcome to Math Practice. This video is about the chapter Triangles and it covers the entire chapter of Triangles of class 9. So watch the video till the end and subscribe to Math Practice. First, some concepts. Two figures are congruent if they are of the same shape and of the same size. For example, if you have two 5 rupee coins minted in the same year and you put one on the other, then it will be exactly fitting. For example, two circles of the same radii are said to be congruent. Two squares are said to be congruent if they have the same measure of sides. If two triangles ABC and PQR are congruent under the correspondence A to P, B to Q and C to R, then symbolically it is expressed as triangle ABC is congruent to triangle PQR. Here the sides AB will be congruent to PQ, sides AC will be congruent to PR and sides BC will be congruent to QR. Note that if triangle ABC is congruent to triangle PQR, it does not mean that triangle ABC is congruent to triangle QRP also. That means when two triangles are congruent, for example, if the congruency is triangle ABC congruent to triangle PQR, angle A will be congruent to angle P, angle B to angle Q, angle C to angle R. Similarly, sides AB with PQ, AC will be congruent to PR and BC will be congruent to QR. So remember, in congruency the order matters. Now, some very important rules for congruency of two triangles. You have to remember these rules. SAS congruence rule. If two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle, triangles are congruent. Same way ASA. If two angles and included side. AAS. If two angles and one side of the triangle are equal to the two angles and the corresponding side of other triangle, then they are congruent. SSS, if three sides of one triangle congruent to other three sides of the other triangle. RHS congruence rule is for two right angle triangles. If in two right angle triangles, hypotenuse and one side of a triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. RHS stands for the right angle, hypotenuse and side. Let us visually see the 5 rules. SSS means you can see both the triangles, the three sides are congruent. SAS, side angle side, means two sides and the included angle of one is congruent to two sides and the included angle of other. ASA, two angles and the included side. AAS, angle side, means two angles and the other side of one triangle are congruent to two angles and the other side of the other triangle. RHS, right angle, hypotenuse and side. Right angle obviously same, hypotenuse should be congruent and the other side must be congruent. Then the two triangles are congruent. Some concepts to remember. Angles opposite to equal sides of a triangle are equal. Same way, sides opposite to equal angles of a triangle are equal. Each angle of an equilateral triangle is of 60 degree. Why? Because the total measure of the angles of a triangle is 180 degree. In a triangle, angle opposite to the longer side is larger or greater. Same way, in a triangle, side opposite to the larger angle is longer. Sum of any two sides of a triangle is always greater than the third side. In congruent triangles, as corresponding parts are equal, we write in short as CPCT, that means corresponding parts of congruent triangles. Also note that SAS congruence holds, but ASS and SSA do not always hold. We are going to prove some important theorems and then solve examples based on different congruence criteria. Theorem 7.2 says that angles opposite to equal sides of an isosceles triangle are equal. Let us prove it. We are given an isosceles triangle in which two sides are equal. So let A be equal to AC. We have to prove angles opposite to them. So angle opposite to AB is C and to AC is B. So angle B and C are congruent. Now, first of all, to prove this, draw the bisector of angle A and let D be the point of intersection of this bisector of angle A with the line BC. So now you have triangles BAD and CAD. Look at the diagram. In the triangles BAD and CAD, AB equal to AC, it is given. Triangle is isosceles. By construction, since it is a bisector, so angle BAD and angle CAD will also be of equal measure. Also AD is equal to AD, common side. So by SAS rule, remember SAS, two sides and the included angle. By this rule, triangle BAD and triangle CAD will be congruent. Hence, all the parts will be congruent. So angle B will be congruent to angle C, or in other words, angle ABD is equal to angle ACD. Hence, we have proved that angles opposite to equal sides are equal. All these results will be helpful in proving the examples. Example 1. In the given figure, OA is equal to OB and OD equal to OC. Show that, first thing, triangle AOD is congruent to triangle BOC and AD is parallel to BC. Always in examples for this chapter, first of all, draw the diagram, and if you want to establish congruence between the two triangles, just notice the two triangles carefully and all the corresponding parts. So first of all, to prove the first result, you have triangle AOD and triangle BOC. So now OA is equal to OB and OD is equal to OC is already given to us. Now, as AOD and BOC, they form a vertically opposite pair of angles. You know that we have just seen in the last video that vertically opposite angles are always congruent. So, AOD and BOC will be equal. So, now what you have? You have two sides and the included angle which is congruent. So, triangle AOD and triangle BOC will be congruent by the SAS congruence rule. So first part is proved. To prove the second part means we have to prove AD is parallel to BC. You already have congruent triangles AOD and BOC from the first part. So by CPCT means the corresponding parts are also equal. So angle OAD will be equal to angle OBC. But just see OAD and OBC, they form a pair of alternate angles, and you know that if alternate angles are congruent, that means the lines are parallel. So AD is parallel to BC. We are going to discuss many different kinds of examples, so watch the video till the end. Second example, in the given figure, line segment AB is parallel to another line segment CD. O is the midpoint of AD. Show that two things you have to show. First thing, you have to show that triangle AOB and triangle DOC are congruent. So first of all, as I told you, first of all consider the two triangles which you need to prove to be congruent. So triangle AOB and triangle DOC. Now you can see that AB is parallel to CD. It is given that AB is parallel to CD. So the alternate angles will be congruent. Angle ABO and angle DCO, they are alternate angles where AB is parallel to CD and BC acts as a transversal. So they are equal. Similarly, AOB and DOC are vertically opposite angles, so they are equal. Also, OA is equal to OD is given to us. Correct? So we have that triangle AOB and triangle DOC are congruent by AAS rule. Second part, you need to show that OB equal to OC. O is the midpoint of BC, means you have to show OB equal to OC. But by the previous first part, AOB and DOC triangles are congruent. So by CPCT means the corresponding parts will be equal. OB and OC will be same. That shows that O is the midpoint of BC. Example 3. Prove that triangle ABC is isosceles if any one of the following holds. First condition, altitude AD bisects BC. Second condition, median AD is perpendicular to the base BC. Remember, these type of things can be used in solving the objective type of questions. So we need to prove it is isosceles triangle. What is given to us in the first case? Altitude AD bisects BC. Since it bisects means it divides into two equal parts, so BD will be equal to CD. What we have to prove? It is isosceles means we have to prove AB equal to AC. Now AD equal to AD, common side. Also ADB is equal to ADC. Both are right angles. Why? Because it is altitude. Altitude means perpendicular. So both are right angles. Also we are given BD equal to CD. So by SAS, two sides and the included angle rule, the triangles ADB will be congruent to triangle ADC. So by CPCT, corresponding parts, AB side will be equal to AC side, and hence triangle ABC will be isosceles. Now second condition for the triangle being isosceles is, if suppose you are having the median, then if the median is perpendicular, then also the triangle will be isosceles. So first of all, let AD be the median. Since it is the median, means BD will be equal to CD. What we have to prove? The triangle is isosceles means we have to prove AB equal to AC. Now angle ADB equal to angle ADC. Why? Because AD is perpendicular to BC, so both will be right angles. Also AD equal to AD, same side. So by SAS rule, SAS rules means two sides and the included angle. So you have the side AD equal to AD, also you have BD equal to CD, and the included angle ADB equal to ADC. So by SAS rule, triangle ADB will be congruent to triangle ADC. So by CPCT, AB will be equal to AC, and hence triangle ABC will be isosceles. Example 4. In right angle triangle ABC, right angle at C, M is the midpoint of the hypotenuse AB. C is joined to M and produced to D such that DM is equal to CM. Point D is joined to B. Show that, first thing you have to show that triangle AMC is congruent to triangle BMD. First of all, let us see the diagram. You have right angle triangle ABC with right angle at C. M is the midpoint of hypotenuse AB. Okay. And what another thing is given? C is joined to M and produced to D such that DM is equal to CM. Now you have to prove two triangles are congruent. As I told you, always try to see and establish the congruency. In both these triangles, DM is equal to CM is already given. Also, as M is the midpoint of AB, AM is equal to BM. Angle BMD and angle AMC will be equal. Why? Vertically opposite angle. So now you have two sides and included angle. So by SAS rule, triangle AMC will be congruent to triangle BMD. Now the second part, we have to show that angle DBC is equal to angle ACB. Now from the first part, we already have triangle AMC is congruent to triangle BMD. So its corresponding parts will be equal. Now you can see that angle MBD, that is same as angle ABD. So instead of angle MBD, I am writing angle ABD. And similarly, instead of angle MAC, I am writing BAC. So both these angles will also be equal. Now since both these angles are equal, and you can observe that you have two lines AC and BD and AB acts as a transversal, then these two angles ABD and BAC, they form alternate angles. So now we have alternate angles are equal. So the corresponding lines will be parallel. So now lines AC and BD will be parallel. Also AC and BD are parallel and BC can also act as a transversal. So BC acts as a transversal for AC and BD, and angle DBC and angle ACB, you can see from the diagram, they both are interior angles on the same side of the transversal. So they form a linear pair. Their total is 180 degree. Hence angle DBC will be equal to angle ACB and both will be 90 degrees. Why? Because angle ACB is 90 degree given. So both the angles are equal and of measure 90 degree. In the third part of previous example, we have to show that triangle DBC and triangle ACB are congruent. Whenever you have to prove the congruency, try to figure out the relationship between the corresponding parts of the two triangles. So now from the part 2 already you have angle DBC and angle ACB are equal. BC and BC is the same side. From the part 1, triangle AMC and triangle BMD were congruent. So its corresponding parts BD and AC are equal. So now by SAS, two sides and included angle criterion, triangle DBC and triangle ACB will be congruent. In the fourth part, you have to prove that CM is equal to half of AB. Now, as we have triangle DBC congruent to triangle ACB, DC will be equal to AB by CPCT. Correct? Now, DC is equal to AB, but it is given that DM and CM are same. Correct? So, instead of DC, I am writing it as equal to 2cm. So 2cm will be equal to AB and hence cm will be equal to half AB. Another interesting example, example 5, AB is a line segment. P and Q are points on opposite sides of AB such that each of them is equidistant from the points A and B. Show that the line PQ is perpendicular bisector of AB. Now from the given diagram, you are having AB as a line segment, P and Q as points on opposite side and each of them is equidistant. Means AP is equal to BP. Similarly, AQ is equal to BQ. This is given to us. Now we have to prove two things. Perpendicular bisector means perpendicular. So we have to prove PQ is perpendicular to AB and also PQ bisects AB. So these two things we need to prove. First of all, let PQ intersect AB at some point C. So now consider the triangles PAQ and triangle PBQ. In these two triangles, AP and BP are equal. AQ is equal to BQ. This is also given. These two things are given. Also PQ and PQ same line is there. So by SSS rule, these two triangles will be congruent. So by corresponding part CPCT, you have angle APQ is equal to angle BPQ. Let this be 1. Now if we consider triangle PAC and PBC, then AP is equal to BP. Already we are given. From the first part we have APC is equal to BPC. Angle APC is equal to angle BPC. Also PC is equal to PC is common. So now what we have got by SAS rule, triangle PAC and triangle PBC are also congruent. So AC will be equal to BC by corresponding parts. So first thing we have proved AC equal to BC means it bisects. Now also you can see that angle ACP plus angle BCP, they form a linear pair. They have one arm common and two opposite arm. They form a linear pair. So the total is 180 degree. But already we have angle ACP and angle BCP are equal. So 2 angle ACP is equal to 180 degree or angle ACP is 90 degree. In other words, it is perpendicular. So from 2 and 3 we can conclude PQ is perpendicular bisector of AP. Next important theorem, theorem 7.8. The sum of any two sides of a triangle is greater than the third side. So if you are given a triangle ABC, we have to prove that AB plus AC is greater than BC. Similarly, AB plus BC is greater than AC and BC plus AC is greater than AB. First of all, produce BA to a point D such that AD is equal to AC. AD equal to AC. Join C and D. Now in triangle ACD, you have AD equal to AC by construction. So the angles opposite to them will be equal. Angle opposite to equal sides are equal. So ADC and ACD, these two angles will be equal, or I can say angle ACD equal to angle ADC. Now on the left hand side we just add an extra angle, angle BCA. So obviously when you add an extra angle, the total measure will be more. So angle BCA plus angle ACD is greater than angle ADC. But what is angle BCA plus ACD? It is angle BCD. Hence we have shown that angle BCD is greater than angle BDC. So sides opposite to the greater angle is larger. Opposite to BCD is BD and opposite to BDC is BC. So BD greater than BC. Now we have BD greater than BC, but what is BD? BD is BA plus AD, or AB plus AC is greater than BC. Why? Because AD is same as AC. So in place of AD just put AC. So we have obtained AB plus AC greater than BC. Similarly, the other two can be showed. Example 6. Prove that each angle of an equilateral triangle is of 60 degree. Suppose triangle ABC is an equilateral triangle. That means all the sides are equal. So AB side is equal to AC. But angles opposite to equal sides are equal. So angle B and angle C will be equal. Similarly, since all the three sides are equal, angle A and B and C, all the three will be equal. But the total measure of the three angles of a triangle is 180 degree. Hence, the measure of angle A, B and C each will be 60 degree. Example 7. P is a point equidistant from two lines L and M intersecting at point A. Show that the line AP bisects the angle between them. We have to show AP bisects the angle means actually we have to show angle PAB and angle PAC are equal. Now first of all, let lines L and M intersect at point A. Let PB be perpendicular to L and PC be perpendicular to M. Now it is already given P is equidistant from L and M lines. So PB and PC will be equal. Now we have to prove PAB is equal to PAC. Consider triangle PAB and PAC. Now PB is equal to PC already given. Angle PBA and angle PCA is equal to 90 degree because perpendicular. Now PA and PA, they are the common ray, so it is equal. Hence by RHS rule, RHS means right angle, the hypotenuse and the side, all the three are equal. So by RHS rule, triangle PAB will be congruent to triangle PAC. So by CPCT, the corresponding angles will be equal. Hence angle PAB and angle PAC will be equal. Example 8. Two sides AB and BC and median AD of triangle ABC are equal to two sides PQ and QR and median PM of triangle PQR. So you are having two triangles in which two sides and a median are equal to the corresponding two sides and the median of another triangle. First thing, you have to prove that triangle ABD is congruent to triangle PQM. So first thing, it is given that AB and PQ are equal. Also BC is equal to QR, that is also given to us. And third thing which is given to us is medians are also equal, AD equal to PM. Now BC equal to QR, so obviously half BC will be equal to half QR. But what is half BC? Half BC is BD. Median means it bisects. So BD is equal to QM because half QR is QM. Hence we have shown that AB is equal to PQ and AD is equal to PM are given and BD is equal to QM. So by SSS rule, the three sides are equal. Hence triangle ABD is congruent to triangle PQM. Second thing, from this we have to show that triangle ABC and triangle PQR are also congruent. So you can see step by step we are proving the congruency. As triangle ABD is congruent to triangle PQM by the first part, the corresponding angles will be equal. So angle B and angle Q will be equal. Also AB and PQ are equal, BC and QR are equal, which is given to us. So by SAS, two sides and included angle are equal. So SAS similarity criterion, we have triangle ABC is congruent to triangle PQR. Example 8. Show that in a right triangle hypotenuse is the longest side. So you are given a triangle ABC and let B be the right angle. So it is a right angle triangle. We have to prove that hypotenuse AC is greater than AB and also AC is greater than BC. Now in triangle ABC, angle A plus C is 90 degree because the sum of three angles is 180 degree. From that angle B is 90 degree. So the sum of remaining two angles A and C is 90 degree. So obviously angle A and C are acute angles, both have measure less than 90 degree. Now angle A less than 90 degree, but 90 degree is the measure of angle B. So we can write as angle A less than angle B. Similarly angle C less than angle B. Now you know the sides opposite to angle of less measure is smaller and of greater measure is bigger. So opposite to A is BC and opposite to B is AC. Hence BC is less than AC. Similarly, as angle C is less than angle B, opposite sides AB less than AC. Therefore, we have shown AC is greater than AB and AC hypotenuse is greater than BC. Now some assignment examples. First one, if line L is the bisector of any angle A and B is any point on L, BP and BQ are perpendiculars from B to the arms of A. Show that first thing triangle APB is congruent to triangle AQB. Here you will be able to establish the congruency by AAS rule. Second thing, BP is equal to BQ by CPCT. Draw the diagram, you will get the result. Second one, in the figure, AB and CD are the smallest and longest side. Show that angle A greater than angle C and angle B greater than angle D. Third one, in triangle ABC, angle B is 35 degree, C is 65 degree and the bisector of angle BAC meets BC in P. Arrange AP, BP, CP in descending order. You have two angles, you can get the third angle and accordingly you can arrange AP, BP and CP. The correct answer is BP, AP and CP. This is the descending order. Fourth one, show that of all line segments drawn from a given point not on it, the perpendicular line segment is the shortest. You can prove this result like we had proved for the hypotenuse. Triangles is an important chapter, so please practice all the examples. Do like and share the video and subscribe to Math Practice. Thank you.